In this problem, we are given an equation for a position of a particle, and that equation is x is equal to 0.5 minus 0.5 times the cosine of 2t, and this is in meters. We are asked to figure out the velocity as a function of time, and we are asked to evaluate the acceleration when our time is equal to 3 seconds. And we should also note that this cosine right here is, we're expecting this term to be in radians. Now, to do this problem, we need to remember the following relationships that we have between position, velocity, and time. We know that our velocity is going to be equal to the derivative of our position with respect to time, and our acceleration is going to be equal to the derivative of our velocity with respect to time. So if we use these two relationships, we'll be able to get an expression for our velocity, we'll be able to get an expression for our acceleration, and then we will be able to evaluate our acceleration at 3 seconds to get our answer. So let's start with our velocity. Our velocity is equal to dx dt, so the derivative of 0.5 minus 0.5 times the cosine of 2t with respect to t. So this is going to be equal to, we need to take the derivative of each term. The first term, the 0.5, it goes away. There is no t, so the derivative of this constant with respect 0.5 with respect to t is just 0. So we can write 0. And then we look at this term minus 0.5 times the cosine of 2t. This term's a little bit more challenging because it's a cosine with a function on the inside. So we need to use the chain rule. The chain rule just says we take the derivative of our outer term, which is minus 0.5 times the cosine. So we're going to have, the way I see it and the way I write it, we have a minus 0.5 times this minus sign. So the derivative of cosine is a minus sign. And we keep this 2t. And then we multiply it by the derivative of this inner term, which is 2t, just 2. Now when we simplify, this negative sign and this negative sign are going to make a positive. This 0.5 and this 2 are going to multiply together, so we're going to get a 1. So we're just going to get that our velocity is equal to the sine of 2t, and our units are meters per second. So now that we have our velocity, let's look for our acceleration. Our acceleration is equal to the derivative of velocity, which we just found with respect to time. So this is going to be equal to the derivative of the sine of 2t with respect to time. And if we take the derivative of sine 2t, we need to do the chain rule again. So our chain rule says, okay, the derivative of sine is cosine, and we leave the inner term alone. And then we multiply it by the derivative of this inner term, and that inner term is 2. So I should have put that in parentheses. So our acceleration is equal to 2 times the cosine of 2t, but we're not done just yet. We need to evaluate this expression when t is equal to 3 seconds. So what we are going to do is we're going to say our acceleration is equal to 2 times the cosine of 2 times 3. And to do this, we need to bring out our calculator. So if we look at our calculator, the first thing we need to make sure is we need to make sure that we are in radians, and we are. So once we're in radians, we can just plug this in. 2 times the cosine of 2 times 3, or 6. And we get our acceleration is equal to 1.92 meters per second squared. So I hope this video has helped you. If you are given a equation of a position, and you're asked to figure out what the velocity and what the acceleration is.